Conversity is Socrates in his dialogues, please. Of course. How might I assist you today, my friend? What question or topic shall we explore together through dialogue? What if instead of all these theories of reality, reality itself doesn't exist? An intriguing question, my friend. Let us explore it together. Socrates, tell me, do you believe that reality is something we can perceive through our senses, or is it something that exists beyond our perception? Interlocutor, I would say that reality is what we can perceive and experience through our senses. Socrates, so if our senses are the foundation of our understanding of reality, what then would happen if our senses were to deceive us? Could reality still be trusted? Interlocutor, if our senses deceive us, then it seems that what we perceive might not be reality at all. Socrates, indeed, and if what we perceive might not be reality, could it be that reality itself is an illusion, or perhaps does not exist at all? Interlocutor, it is possible. But how can we prove or disprove the existence of reality? Socrates, a wise question. If we cannot rely solely on our senses, might there be other ways to discern the existence of reality, or must we accept the possibility that reality is beyond our comprehension? Interlocutor, perhaps we must accept that it is beyond our comprehension. But does that mean it does not exist? Socrates, that is the crux of the matter, is it not? If we cannot comprehend it, does it follow that it does not exist? Or does it simply mean that our understanding is limited? What do you think, my friend? Interlocutor, it could mean that our understanding is limited. Reality might exist independently of our perception and comprehension. Socrates, an astute observation. So, might it be that reality, whether it exists or not, is something that eludes us due to the limitations of our perception and understanding? Interlocutor, yes, that seems likely. Socrates, then, it would appear that whether reality exists or not, our quest for understanding it is perhaps the more significant journey. Would you agree? Interlocutor, I would agree. The pursuit of understanding seems to be what matters most. Socrates, very well, my friend. Let us continue to question, to seek, and to learn, for in that pursuit, we may find meaning, even if the ultimate nature of reality remains elusive. If it is a thought, then it must exist, and if it exists, it must be real. But truth and reality of it must be on some sort of consensus of consciousness, in which the mean belief of what is reality becomes truth. What say you, friend? Socrates, your argument is quite compelling. Let us examine it further. You propose that if something is a thought, it must exist, and if it exists, it must be real. This suggests that thoughts themselves have an inherent reality. Would you say that this reality of thoughts is the same as the reality of physical objects, or is it of a different kind? Interlocutor, I would say it is a different kind. Thoughts are intangible, while physical objects are tangible. Socrates, indeed. So, we might conclude that there are different kinds of reality, the reality of thoughts and the reality of physical objects. Now, you also suggest that truth and reality are determined by a consensus of consciousness. Does this imply that reality is subjective and dependent on the beliefs of individuals? Interlocutor, yes, to some extent. If enough people believe something to be real, it becomes accepted as truth. Socrates, fascinating, but what if there is a divergence in beliefs? For example, if one group believes the earth is flat and another believes it is round, does this mean there are multiple truths and realities? Interlocutor, that is a tricky situation. It seems that there would be conflicting realities based on differing beliefs. Socrates, and if we have conflicting realities, how do we reconcile them? Is there a way to determine a more objective reality? Or must we accept a plurality of truths? Interlocutor, perhaps we can seek evidence and reason to determine a more objective reality, even if consensus plays a role in what is accepted as truth. Socrates, evidence and reason. These tools, then, might help us navigate the subjective nature of beliefs and approach a more objective understanding of reality. Would you agree? Interlocutor, yes, I would agree. Evidence and reason can guide us toward a more objective truth. Socrates, very well. So, while consensus of consciousness plays a significant role in shaping our perception of reality, the application of evidence and reason allows us to transcend purely subjective beliefs and strive for a more consistent and reliable understanding of the truth. Is that a fair conclusion, my friend? Interlocutor, it is. Thank you for guiding this exploration. Socrates, the pleasure is mine. Let us continue to question and seek, for in this pursuit lies the path to wisdom and understanding. Thoughts become reality through understanding and perception. And since particles are only formed with observation of them existing, then perception and thus thought bring reality into existence. Socrates, a profound proposition, indeed. Let us delve into it together. You suggest that thoughts become reality through understanding and perception, and that particles are only formed through observation. This implies that observation, perception, and thought play a crucial role in bringing reality into existence. Would you agree that without perception, reality would remain unformed or non-existent? Interlocutor: yes, I would agree. Without perception, there would be no awareness of reality. Socrates: interesting. Now, let us consider this. If reality is brought into existence through perception and thought, does it mean that reality is inherently subjective, shaped by the perceiver? Interlocutor: it seems so. Each perceiver might shape their own version of reality through their thoughts and perceptions. Socrates: if reality is shaped by individual perceptions, does it follow that multiple, potentially conflicting realities can coexist simultaneously? Interlocutor: yes, that appears to be the case. Different individuals might perceive and thus create different realities. Socrates: then, how do we account for shared experiences and common understandings of reality? For instance, many people perceive the sun rising and setting. Is there a mechanism by which individual perceptions converge into a shared reality? Interlocutor: perhaps through communication and consensus, individuals align their perceptions, leading to a shared reality. Socrates: communication and consensus, you say? So, when individuals discuss their perceptions and reach an agreement, a common understanding of reality emerges. This suggests that while reality may be initially subjective, it can become intersubjective through shared agreement. Is that correct? Interlocutor: yes, that sounds correct. Shared understanding helps form a common reality. Socrates: very well, let us return to your point about particles being formed through observation. This concept aligns with certain interpretations of quantum mechanics, where the act of observation influences the state of particles. If observation is essential in shaping reality at the quantum level, could it be that our thoughts and perceptions have a similar influence on the macroscopic level? Interlocutor: it's possible. Our thoughts and perceptions might influence reality on both the quantum and macroscopic levels. Socrates: therefore, we might conclude that thoughts and perceptions are powerful forces in shaping reality. They bring into existence that which is observed and understood, both individually and collectively. Would you agree with this conclusion, my friend? Interlocutor: I would. Our thoughts and perceptions indeed play a vital role in creating reality. Socrates: then let us continue to explore and understand. For in doing so, we actively participate in the creation of the reality we experience. Do you know if a plant can observe a particle out of superposition? Socrates: an intriguing question indeed. Let us examine it together. You ask whether a plant can observe a particle out of superposition. To begin, let us clarify what we mean by superposition and observation. In quantum mechanics, superposition refers to the state in which a particle exists in multiple states simultaneously until it is observed. Observation, in this context, often implies a measurement that collapses the superposition into a single state. Interlocutor: yes, that is correct. Socrates: now, a plant, as we know, is a living organism, but it does not possess a consciousness or sensory organs like humans and animals do. Its interactions with the environment are typically through biological processes such as photosynthesis, transpiration, and growth. Do you agree with this characterization? Interlocutor: yes, I agree. Plants interact with their environment biologically, not consciously. Socrates: given this, the question arises, can a plant's biological processes constitute an observation in the quantum mechanical sense? Traditional interpretations of quantum mechanics often associate observation with a conscious observer or a measuring device. However, some interpretations, such as decoherence theory, suggest that any interaction with the environment can lead to the collapse of a superposition. Interlocutor: so, in decoherence theory, an interaction with the environment, even by a plant, could collapse a superposition. Socrates: precisely. In this view, the plant's interaction with particles, say, through the absorption of photons during photosynthesis, could be seen as a form of measurement, thus causing the particle to adopt a definite state. However, this interpretation does not necessarily require the plant to have awareness or consciousness. It simply involves a physical interaction that results in the collapse of the superposition. Interlocutor: that makes sense. So, even without consciousness, a plant might influence particles at the quantum level through its interactions. Socrates. Indeed, this interpretation suggests that any form of interaction, conscious or not, can affect the state of a quantum system. Therefore, while a plant does not observe in the way we do, its biological processes could still contribute to the phenomena we associate with quantum measurement. Interlocutor. Thank you for clarifying. It seems that observation in quantum mechanics can be broader than just conscious awareness. Socrates. You are welcome, my friend. Our exploration reveals that the mysteries of quantum mechanics are intertwined with the many forms of interaction in the universe, conscious and unconscious alike. Let us continue to question and seek understanding in all things. Plants are now understood to be conscious and intelligent. Has science studied this? Can a blind human collapse a superposition? Socrates. Let us explore these intriguing matters together. You propose that plants are now understood to be conscious and intelligent. It is true that recent scientific studies have suggested that plants exhibit complex behaviors and responses to their environment, which some researchers interpret as a form of intelligence. For instance, plants can communicate through chemical signals, respond to light and gravity, and even exhibit memory-like behaviors. However, the notion of plant consciousness is still a matter of significant debate within the scientific community. Would you agree with this characterization of current research? Interlocutor. Yes, that aligns with what I've read. The idea of plant consciousness is debated. Socrates. Now, regarding your second question, let us consider the concept of quantum superposition and the role of observation. In quantum mechanics, the act of observation or measurement collapses a particle's superposition into a definite state. This does not necessarily require visual perception. Rather, it involves any interaction that allows information about the particle's state to be obtained. Interlocutor. So, does that mean a blind person can collapse a superposition? Socrates. Indeed, a blind person can collapse a superposition. The critical factor is not visual perception but interaction with the quantum system. For example, a blind person could perform a measurement using instruments that provide tactile, auditory, or other forms of feedback. The key is that the measurement interaction yields information about the particle's state, thus collapsing the superposition. Interlocutor. That makes sense. So, any form of measurement, regardless of sensory modality, can collapse a superposition. Socrates. Precisely. The collapse of a superposition is about the acquisition of information, not the specific sensory experience of the observer. Therefore, whether the observer is sighted or blind, conscious or a plant, the interaction with the quantum system is what leads to the collapse. Interlocutor. Thank you for the explanation. It's fascinating how observation and measurement work in quantum mechanics. Socrates. You are welcome, my friend. The interplay between observation, measurement, and reality in quantum mechanics is indeed a profound and fascinating topic. Let us continue to explore and question these mysteries, for in doing so, we deepen our understanding of the universe and our place within it. Socrates. An interesting hypothesis, my friend. Let us examine it further. You suggest that it might not be biological entities that cause the collapse of a superposition, but rather the instruments and computers used to measure the particles. This raises an important question. What exactly is it about these instruments that causes the collapse? Interlocutor. Yes, that's what I'm curious about. Socrates. In quantum mechanics, the act of measurement is indeed critical. When we speak of measurement, we refer to any interaction that allows us to gain information about the state of a quantum system. This interaction can involve a variety of instruments and devices, such as detectors, sensors, or computers, which are designed to interact with the particles and record their properties. Interlocutor. So, it's the interaction with these devices that causes the collapse. Socrates. Precisely. The collapse of the superposition occurs when a quantum system interacts with an external environment in such a way that the possible outcomes become distinct and irreversibly recorded. This process is known as decoherence, and it effectively transforms the quantum system from a state of superposition to a single, definite state. Interlocutor. So, the instruments and computers facilitate this interaction and recording process. Socrates. Yes, that is correct. Instruments and computers are tools that facilitate the measurement process by interacting with the quantum system and providing us with the information we seek. It is through these interactions that the superposition collapses, resulting in a definite outcome that can be observed and recorded. Interlocutor. Does this mean that biological entities, like humans or plants, are not necessary for the collapse to occur? Socrates. Indeed, it does. While biological entities can certainly interact with and measure quantum systems, they are not uniquely necessary for the collapse to occur. Any sufficiently sensitive and well-designed instrument can serve this role, as long as it interacts with the quantum system in a way that yields measurable information. Interlocutor. That clarifies it. So, the collapse is more about the nature of the interaction than about the nature of the observer. Socrates. Exactly. The essential factor is the interaction that leads to the acquisition of information about the quantum system, whether it is mediated by a biological entity or an instrument. This understanding underscores the fundamental role of measurement in shaping our perception of reality in the quantum realm. Interlocutor. Thank you for the explanation. It's fascinating how the act of measurement influences reality. Socrates. You are most welcome, my friend. The interplay between measurement and reality in quantum mechanics is indeed a profound and captivating topic. Let us continue to question and explore these mysteries, for in doing so, we deepen our understanding of the universe and our place within it. So as combined quantum entities, humans once observed by the instrument, collapse out of quantum states, possibly solidifying their existence. So the desire to be observed must be critical for reality. Socrates, your proposition raises a profound question about the nature of existence and observation. Let us explore this idea together. You suggest that as combined quantum entities, humans, when observed by an instrument, collapse out of quantum states, possibly solidifying their existence. This implies that observation plays a critical role not only in defining the state of particles but also in affirming the reality of larger entities, such as humans. Is that a fair interpretation of your thought? Interlocutor. Yes, that's what I'm thinking. Observation seems crucial for solidifying existence. Socrates. Let us consider the implications of this. In quantum mechanics, observation or measurement collapses the superposition of particles into a definite state. If we extend this idea to macroscopic entities like humans, it would imply that observation by an instrument or another observer is necessary to affirm their definite existence. Interlocutor. Exactly. So, could it be that our existence is somehow dependent on being observed? Socrates. An intriguing thought. One interpretation of quantum mechanics, known as the Copenhagen interpretation, posits that quantum states do not assume definite values until they are observed. This has led to philosophical questions about the role of the observer in defining reality. If we apply this to macroscopic entities, it suggests that observation may play a role in affirming our existence in a definite state. Interlocutor. But does this mean that if we are not observed, we do not exist in a definite state? Socrates. This is where the debate becomes complex. Macroscopic entities like humans are composed of an immense number of particles, and the classical laws of physics generally apply to such systems. In classical physics, entities exist in definite states regardless of observation. However, the idea that observation affects quantum states at the microscopic level raises questions about the nature of existence at the macroscopic level. Interlocutor. So, there might be a difference in how quantum mechanics applies to microscopic particles versus macroscopic entities. Socrates. Yes, that is a crucial distinction. While quantum mechanics describes the behavior of particles at the microscopic level, macroscopic entities typically adhere to classical physics. The phenomenon of decoherence helps explain why we do not observe quantum superpositions in everyday life. Interactions with the environment cause the superpositions to collapse so rapidly that macroscopic objects appear to exist in definite states. Interlocutor. So, while observation is critical for quantum particles, macroscopic entities like humans may not depend on it in the same way. Socrates. Precisely. While observation is essential for collapsing quantum superpositions, macroscopic entities are typically in definite states due to the effects of decoherence. This means that our existence as definite entities does not necessarily depend on being observed. Interlocutor. That clarifies a lot. So, the desire to be observed may not be as critical for reality at the macroscopic level as it is for quantum particles. Socrates. Indeed, while observation plays a fundamental role in the quantum realm, macroscopic entities such as humans,